I'm Mark Bostic, Chairman of the Green Building Council of Greater Columbia. We're at the Parade of Homes. As you can see, we're still working on the Parade of Homes. We wanted to get here a little early and go over some of the energy features and some of the things in these houses that we're making them high performance homes this year. We've got 3 homes in the parade that are high performance, built to our CHIP program, Certified High Performance Homes. And we're going to show you some of the things that make these houses different than regular construction. And we're going to show you some of their features, and hopefully you'll want one. So we're going to look around with some of our builders. We'll talk to a couple builders, talk to our energy raters, and try to explain this process to you. Here we go. Basically, we're building to the National Green Building Standard, and that's the program that we're using for our CHIP homes. CHIP stands for Certified High Performance Homes, and we're up to close to 300 houses have been built in Columbia this year on this program. And what these builders are discovering is the houses are more livable, better air quality, better temperature-wise, and lower power bills, which is huge. There's 2 or 3 concepts that have to come together that hadn't come together in the past. What we do is use an energy rater to ensure that each phase of construction meshes together, is built properly, so that they all work together and deliver you a better feel in your house while using less energy. If you just leave it up to one subcontractor without the others, you can miss it greatly. So if you do your heat and air right and don't do your air seal right, or both of those and don't do your insulation right, you can have a problem where you don't have enough air conditioning to handle your house, and it's not going to serve your needs. So by putting all 3 of those parts together and making sure each one is right, then we get a superior performing house that keeps you comfortable and uses a huge amount less energy. We'll get into that a little bit later, of course. So we're going to look around some of these houses. Right now we're in the Dunbar house that's built to the CHIP standard. The Tuttle house is built to the CHIP standard, and also the Essex house. So when you're in these 3 houses, check out some of these features that we're going to show you. Each of these builders took a little bit different path to get to the end result, but they all scored enough points in our system to be certified, and we're proud to have them as members of the CHIP community. Most of the things that we're going to do in these houses are things that you're not able to see. Although this house looks like a conventional house, looks like an everyday house everybody'd love to have, that's what greenhouses are supposed to look like. And what we're going to do in this house, what we have done, of course, already, is they've gone back to basics, and they've designed this heat and air system for the loads in the house. So what they do is they do an actual heat loss and gain by room on every house and design the system to it. There's a thing called a manual J that helps them size their system. There's a manual D that helps them size their ducts correctly. Make sure they have enough returns, make sure they're in the right places, the air gets to where it needs to go, and it's not just hodgepodge anymore. It's not just put a bunch of pipes in your attic and run a duct to every room. What we're doing is actually designing these houses the same way they do commercial systems, so that the right air gets to the right place and you get to operate in a much more efficient situation. Hi there. We're going to look today at how some of these builders are putting the high performance in their high performance home. This is a little bit out of the box. Some of my builders achieve things a different way than this, but this is a real good place to start. We're going to show you, we're in the Dunbar home, we're in the attic. It's a very nice temperature up here. It's just like it's air conditioned. In fact, really, it is. What they've done, instead of insulating the wall between the living space and the attic, is instead they've encapsulated the whole attic with the spray foam. And what it does is it seals the house around the perimeter, and all the heat and air systems are inside the envelope with you. So instead of it being 150 degrees like it might be in your attic right now it's very comfortable, semi-conditioned space. Any cooling that may radiate out of the ductwork, the units, any of those things are all operating in a controlled environment in a much cooler temperature, and they're saving energy. So we're going to walk down here and let you see how this works out. This is not the cheapest way Spray foam's a little more expensive, but if you use it in the right manner and use it in the right places, it's a real good way to get the energy numbers you're trying to get. So we've got our heating and air systems. This is a good way to show you how these units are sealed up much better. They have mastic all around the joints, mastic at all the connections. The units are real high efficiency, and by being in this sealed environment, they really work like they're supposed to. Now, one of the things that happens in heating and air is we've gone from the old days when it was 600 square feet per ton, and your heating and air guy sized your system based on worst case scenario. He didn't know how well your house was sealed. He didn't know how well your house was insulated. Now we control these other factors, and we get the same environmental air quality and temperatures using much less equipment. So you may cut your heating and air load by doing it right to 50% to run your house over what it was the conventional way. So we can pull, even those units are more efficient, a little bit more cost, we pull enough tonnage out of the size of them, in some cases 50% less. So you can save a little money on your heating and air cost to cover some of the other costs, and it makes everything even out. What we're trying to do is make these new houses perform as well at the same cost, perform better at the same cost as conventional construction. That's our goal. Special treat, we corralled another builder. You know how hard that is during Parade Homes Week? Now everybody's going at it around here, but we've got our builder standing next to us. I want to ask him a couple questions and let you see how well he likes doing these houses. And that's my question. You've been building these houses, high performance houses, for over a year now. I've been drawing houses, high performance, over a year. It's been a couple of years. We're getting more and more under our belt. Tell me about your thoughts on building a house, high performance, and your customer reactions that you've had. Okay. How does it change your business?
Thank you, Mark. In fact, we've been doing it for about 7 or 8 years. We discovered the open cell foam insulation about 8 years ago, and we did it on a couple of houses, and it had a dramatic effect on utility bills. And then over time, we've done more and more of them. We did a Parade Homes house 5 or 6 years ago with foam insulation and upgraded heating and air equipment. And we're finding customers are more and more interested in that because electric bills are going up, coal plants are going away, and energy costs are not going anywhere but up. So we found that we could build a high performance house, you call it. The basic things that we do are tankless water heater, high performance windows, 15-seater air conditioning equipment, foam insulation, and we experience about 50% reduction in utility bills as a result. And when I tell that to people, it gets their attention, because you take a $400 or $500 house, such as the one we're in, this house should experience something under $200 a month in utility bill. And that's a big number when you factor it into overall operating costs, mortgage rates, and all that kind of thing. $200, $300 a month in savings is very important.
Well, I'm sold, and obviously you're sold. How is your customer feedback?
Well, it's been very good. In fact, we've had, as you know, Joe Gilmore does our analysis for us, and Joe did one over in Saluda River Club last year, 4,500 square foot house. We figured the bill on it would probably be around $450 a month. With the performance features we included, it was estimated to be $215 a month, and the customers are actually experiencing better than that. So it's been proven to be more than just talk. It's what they're really experiencing.
I tell you, it's a great time to be a home builder. It's a great time to be in the business. All the new homes, everybody's new home is performing better than the homes in the past just by changes in the code. But what you want to remember is you want to be looking for a CHIP home, certified high performance. We're going above the code. We're going into places, the uncharted territory for a regular builder, so to speak, and you're getting these much better returns on your energy bills and having a super comfortable house that you're proud to live in, proud to show off to your neighbor. Okay, we're going to look at some outside stuff for a minute. This right here is, you've heard a lot about these tankless water heaters. This one's a Rheem. They have Rinnai's. They have several brands. They're really overtaking the market. They're a good way to save energy. What you're not doing is storing a huge tank of hot water all day, all night when you're not using it. What happens when you turn on the faucet? This thing starts to run, starts making your hot water. When you turn the faucet back off, it goes off. So they run on gas. It's real efficient, and it's a good way to save energy. It's also a good way to have enough hot water all the time whenever you need it, never run out. That's another thing when you got teenagers, I guess. One more fact is you want to look at placement of these. If you put them on the outside of the house, they vent directly from the unit. You can save, not have to buy the vent stacks that go up through your house. That's economical. You want to look at placement. Try to get them as close to your bathroom or your kitchen as you can get them. Sometimes we'll go with one large unit. On some houses we'll go with more than one unit near to each place that you're using the water, so the runs are shorter. So that's kind of how these work. They're very popular on chip homes now. A little bit about when I'm designing these greenhouses. There's a fella that comes along behind me, and he's called the Energy Rater. And he's the guy that does the energy calculations, helps people choose the heat and air system they're going to use, how they're going to insulate, how he's going to help them find the path to get between them to their green home. And one of the best in the business is my buddy Joe Gilmore. He's my Energy Rater that I use. And he's the fellow that's doing some of these houses out here at this show. And Joe just wanted to meet you and tell me a little bit of perspective about testing these homes and how much homes have improved since we've started doing this.
Well, Mark, the testing is really quite straightforward, and the improvement we've seen in the performance of the homes and livability is just unbelievable. We're seeing 50% as a norm when everything's done right and tested out. Of course, we always are concerned with making sure that we test for air infiltration. When I get your design, the first thing I do is model that house as if it's standard. And I put everything in the house that's going to be in it when you're living in it. And in order for it to work, it means we have to hit the numbers that we specify for infiltration and for duct leakage, because we size everything exact. And your home is a complete system. It's not just a collection of parts. So all parts of it have to balance and work together.
So actually, you're the guy, you're going to on-site test, you're going to test for air leakage at the end, you're going to test the ducts during the program, you're also going to do a few on-site inspections, and you're going to be looking for if the insulation is installed properly and that they've used the proper equipment, as well as startup procedures for some of these new high-tech heat and air systems, right?
That's correct. We're like the third set of eyes. We make sure everything's done right before we move to the next stage. Like, for example, there can be no drywall installed if the insulation isn't correct, or if all the air sealing hadn't been done. So we're making sure it's all done before we give the thumbs up for drywall. Then we come back again and we're testing right beside the HVAC contractor when he starts these systems up to make sure we got the air flows and the refrigerant service levels that we need. And of course, when the house is complete, we come back, do a complete inspection plus physical testing to make sure everything stayed the way it's supposed to.
It all gets kind of complicated. That's why you got to have a guy like Joe. When you're building a house with this many parts, whether it's a production house or a full-on custom house, it's good to have that extra set of eyes. Helps you pull all your trades together, make sure they're all working as a team to build a cohesive unit, and you're going to get a house that gives you better air quality, more comfort, and lower power bills.
One of the great things that's going on are these nice quiet units here. And it's not too long ago, a house of this size, this house is over 5,500 square feet. A few years ago, there have been 13, possibly 14 tons of cooling just to carry this house. Today, we're carrying it with 6 tons. And we're able to take the temperature where we want it and the humidity. And of course, you take control of humidity, that's your comfort. And since we're able to take that humidity and keep it between 50 to 45, it feels a whole lot cooler in the house than it really is. And it saves your energy.
Now really, in the old days, you just depend on the heat and air contractor to deliver this kind of performance. But he wasn't able to do it by himself because he can only control heat and air. Couldn't control air seal, he couldn't control what the insulators did, couldn't control the windows that you used or any of that kind of stuff. So what they do typically is they'd oversize these units to make sure that under worst case conditions you're comfortable. That led to huge sizes of units and poor energy performance. But by taking this approach where we combine all these things at one time, we know what the windows are going to be, we know what the load's on the house, we know the sun angles, we know that it's been insulated properly, and we know these other factors, Then we're able to do the actual calculations for this house and pull the units down so they're the right size. You save a little money for not having to buy so much heat and air that you can put in your air seal and some of your other strategies. And you get a unit that gives you a house that's comfortable and up to a 50% power savings in your power bill.
And one thing that's really noticeable is the quietness of the system in the house. Most people will not realize when the system's on versus when it's off when you're inside. There's virtually no air noise from the airflow coming in. It's that precisely balanced.
Good things to know, and of course Joe's the guy that verifies when he's doing his checklist and doing his certification stuff. He'll verify that these are the units with the proper SEER. It was in the game plan. It's not necessarily to buy the most expensive SEER units. You just have to get enough to get your game plan to work with the way you're trying to build your house. It works for all different budgets, and then Joe will verify that the game plan is the units that they put in to meet the proper SEER that we started out with our goal and get us to where we want to be.
That's it.
We're going to talk a little bit about outside water quality, and that's one of the parts of the CHIP program, of course. And what you want to do when you're building these houses is you want to set up your irrigation system so that the turf grass is on a separate set of heads than the plantings are. And that way you can run the timers at different lengths and get it to work exactly the way it wants. And you save water in the process and you conserve and have less water bill. One of the other cool things, I didn't really realize this till somebody pointed out to me, but this pine straw is some sort of composite. It's not really real. It's made to last longer. It looks exactly like real pine straw, but it's made to last longer and not have to be changed out so much. In fact, it may be permanent. That's some really cool stuff, and nobody's pointed out, you never know. Let's go on inside. Our energy rater setting up inside, so this is the blower door he's going to use. So he's got it hooked to the door. When he cranks it up, the fan speed is hooked to a computer. And there's a little hose that's on the inside, a little hose that's on the outside, so he's got air pressure from each side. It's going to show exactly how much this house leaks and make sure it's tight enough to meet the standards that it's supposed to be. We just happen to see this here. What we were really looking for is some of this painting action going on in this house. And of course they've got notes everywhere of what colors go on which house and kind of get everything the right way. So what we were hunting up is some of this actual low VOC. In fact, this is actually zero VOC paint. So what that means is it's low volatile organic compounds. So it doesn't put out any compounds into the air when you paint it. So it's good for a greenhouse. You're sealed up inside. You want to use these paints to give you better air quality. The real benefit, cool part about these paints is even though we'll go in this house and they're in the middle of painting it, you won't smell any paint. There's no paint smell. Paint smell is volatile organic compounds. So when you take that out, the smell goes away. So it's a real cool thing, especially when you're painting around the house. Okay, we're in the pantry, and we're in the pantry because this is where the panel boxes are for this house. And what we're going to do when this house passes certification and gets all this energy testing, blower door test, all those kind of things, and gets certified by the rater, it gets one of these high performance home badges, goes right here on the panel. It's going to have a certification date and a certification number. You can track these. If you're looking for high performance homes, you can see where they're located on the ColumbiaBuilders.com website. And if you happen to go in a house and you want to see if it's certified, go to the panel box, look and see if it has this sticker. This house will probably also end up with an Energy Star sticker that goes right underneath our sticker here. And that's the way that you tell that you've got a house that's certified in the CHIP program. Water quality is big in these high performance homes, and we get to show you some cool things. Of course, with Parade homes, you're going to see the nicest stuff there is to see, but I'm going to show you some of the other stuff too. If you look up at the ceiling, that's what you call an Energy Star bath fan. And those are the bath fans that you want to get. They're real quiet, they're high performance, and they pull the air out, and then when they hook them up, they make sure they all go out to the outside of the house instead of just dumping someplace in your attic. So those are key to the program. We got low flow water fixtures, and you can get just anything you need in that. Great thing about this is the manufacturers really stepped up and they're giving us the products that we need to deliver. And what your builder does is he puts his knowledge together with those products and gives you the house that you need to have. Of course, we don't have a shower enclosure yet. In fact, this one may not get one. we'll have to see. We'll come back and take a look. This real cool shower, it's a roll-in, so it's go in without a threshold. The drain's in the back, so that's one of the new strip drains that they have in showers. You really get a great look, and all the water runs to the back of the shower and runs out that drain. So even if we'll come back and see if they have glass on this. Even if they don't, I'm pretty sure you can get a pretty good shower in here, and not even need a threshold. No house would be complete without low flow toilets. They've really raised the bar on these now. They really give you the flushes that you need and all the performance, but you use a whole lot less water than the old ones did. One cool little thing that we got on the wall in here is this is a real good place to put your controller for your water heater and your tankless water heater. And what they do is you can set the temperature to whatever you want it to be, and it'll stay there. And then this cool little power switch, that's only if you have teenagers. So if your teenager gets in the shower and he stays in too long, you just come out here and you push this button and he'll get out of the shower. Now, us guys that have these tankless water heaters realize that's the only way to get your kids out of the shower. Alright, we're on to the next place. For us geeks, before the house is done, it's exciting stuff. You know, after it gets all prettied up with the furniture, we're not so excited. One of the things I wanted to show you real quick was right here, these heating and air ducts have been masticed. So what they do is they seal them all up. You need the joints in there. They seal it up with goo. What that does is keeps you from getting any air leakage and loss. The older heating and air systems didn't do that. So that's one of the things that really helps these high performance homes when they put the blower door test on this house. They've caulked the shoe all the way around the exterior wall. They've used the wallboard sheathing that seals up the house. They flash the windows correctly. When they pump that thing to this house, it's going to really give them a good number. Another reason I'm here is to show you windows. Windows are so much better, even by code. And of course, now our green building guys are above code. We're not using the regular energy code. We're using the green energy standards, which is a step above the regular code. And happy to do it. But even the code windows, all of them come down, they're low E. They don't have the stickers on them now, they cleaned them off, of course. But when you look on these windows, there's a sticker with 3 numbers. And those 3 numbers will give you the actual advantages of those glass and the performance. You can use those numbers with your energy rater to look at different brands of windows and see which ones are right for you, giving you the right numbers. You want a certain amount of visual clarity and a certain amount of energy reflectivity. It's called the E factor. You know, when you put all those together and combine that with the tightness of the unit itself, you find out how well your window is going to perform, and you know what you're going to get before you get it. So that helps you when you're shopping for windows. Found a cool programmable thermostat. Everybody loves high tech. One thing that this does is it's monitoring your temperature, of course, 70 degrees in this house, but it's also monitoring your humidity. Right now we're at 59%, but they've just powered this house up. So as it dries, the paint dries, all the things dry, your humidity level is going to come down. And one thing that you want to watch is when you do these high performance homes, you need to put less tonnage in them, because if the unit doesn't run long enough, it doesn't take the humidity out of the house. So your humidity level gets up above 60% or 65. You can be at 70 degrees and still not feel like you're at 70 degrees. It's too muggy. So as you pull the humidity down, you'll find out that you're more comfortable in one of these newer houses than you were in your old one. You can even bump the thermostat up to 72, 73, 74, and the air is drier because the humidity's gone, the unit's run long enough, and you're going to be more comfortable. So we're getting reports back that even though our guys are saving energy, and the thermostats are maybe a little higher than they were in their last house, they're still much, much more comfortable. And comfortable is really the name of the game in a high performance home. Okay, we're at the Parade of Homes. We're only a week away from the Parade of Homes starting, so we're really lucky to get a builder to sit down with us and talk to us and all this hectic stuff we got going on here. But with us we have Julie Jones with Teleconstruction. She is the mastermind behind this particular home. And really, we've got you here today. You're building these houses, have been for a couple of years. Tell us the advantages of building this way, how you've adjusted to it, and are your customers happy with the results?
Yeah, of course. We've really enjoyed getting to be a part of the CHIP program and follow along with a lot of the NAHB protocols as far as green certification and high performance homes go. We've seen great feedback from our customers. One of the best things I think about it is that you're able to model it up front, understand what your payback could be if you did certain things, so it's not a guess anymore. It's scientific, and then we prove it by doing the testing and getting a HERS rating, and we're able to show how well we've built our homes. So that's what I really enjoy about it. Our customers get great utility bills. I always get a phone call, just kind of a shocked phone call about how it worked and how they're really impressed with how we built it. But it does take time. It takes a lot of energy up front, but it's totally worth it to make sure all of our components are working together and are going to perform for our clients.
It's great to know these builders are doing the upfront effort, really building a quality home, and now we have a way to measure it and the public can see exactly how great they are. We're going to sneak in the Essex home and see some of the cool things they have in this particular home. But before we go in, when you look at the exterior of these houses, of course they look like a regular house. They're supposed to. That's what we're doing here. But they got features that are designed in to help them with their chip points. And one of them is you want to use covers over your porches if you can. Porches are great to keep the water off the door. All your doors last longer, they don't rot out. So we're looking for covered porches. We're looking for enough overhang from these roofs to protect these windows and the walls on the outside. Of course, when you're in designer mode, you're thinking about orientation, which way the sun comes up and which way the sun goes down. When we send them to the energy rater evaluates the house and the position on the lot. So he pulls all the sun angles in, and he uses those numbers to help him compute the heat loss and gain for each room in the house. So when we get done, we know we're going to comply. We're going to give everybody the comfort they need, and we're going to give them the energy savings that they're looking for also. So let's go on in. We'll take a look inside. Hi, we're in the Essex attic, so we're going to show you some real cool stuff about this house. To start with, they built this house using trusses. So what they're doing is they're using the 2x4 lumber for structural element instead of the thicker, heavier 2x10 stuff. So that saves the trees. It's a little more efficient. The forestry grow a little bit faster. You still get a good quality house. These guys, it's all pre-made, so it comes out here. There's no waste, sun, that kind of thing. Now, some other cool stuff in this attic is a lot more comfortable staying in this attic than it would be in your conventional attic. And one of the reasons for that is the sheathing. So what they're doing is, this is Energy Star rated sheathing, and it's got a reflective coating on the bottom of it. What it does is it reflects the heat from the shingles back out of the house. So it'll keep your attic up to 50 degrees cooler than the conventional way. So if you put your ductwork up here in the attic with it, it's in a much cooler environment than it would be otherwise. Now, we looked at the foam in the other video. We got the sheathing in these. They don't mix, so you either use one or you use the other, depending on the way you're trying to get. So these guys have used the reflective sheathing, which is good. They've blown their blown insulation up to an R38 or better. Some guys go a little bit even thicker than that. And what that does, seals the house away from up here in the attic. All this ductwork is sealed. And the older houses that you might be in, the ductwork leaks a lot more than this. So if you're getting 20% duct leakage in your house, you lost that air. When the return pulls a vacuum, it starts pulling air through the can lights and through those other things. And that's not good. So what we've done in these new houses is we've sealed all these units up so they don't leak any air in the attic at all. They actually put a test on them to make sure they don't leak. And then we seal the envelope. We use new can lights that don't leak, not vented to the attic. And we actually pressure test these houses at the end with a blower door test, and actually test the integrity and tightness of the house. So you get a measurable scale. Each one of these houses gets a HERS score, and we know how efficient it's going to be from the start. And all these guys doing quality work like this, real proud to put their HERS score on their house. I'll show you how well. One more thing I want to show you coming down this attic stair. These new attic stair units are a lot better than the old ones were. They got a refrigerator seal around this, so when you close the door, you're not able to get so many leaks between the house. And it's the air pressure imbalance. The duct leakage and the return pull and return air is what makes air coming in and out of these holes. When you put these refrigerator seals on these and use these newer stairs and newer access doors, they work much better, save you a lot of energy. We're in a closet right now. A minute ago I showed you about the the attic stair. Now we're working the same thing on these doors. They make door units for these now, and they seal up. They got the refrigerator seal around the inside of them. You got the insulation goes into a pocket. This one's actually got an Energy Star sticker on it. And then one more thing you want to look at when you're doing one of the techniques, not all the guys are doing it, but some guys are, is if you seal this insulation behind this wall in a box, it performs vastly superior to insulation that's just open. So what you want to do is seal it on 6 sides. So it's the top and the bottom. Inside is the drywall. And if you reach around the back, this one's got a board over the insulation. So the insulation is encapsulated in a box. That's what starts getting you superior bonus room temperatures, temperature control. It stays the same temperature as the house. Losing a lot of air out of the older houses from not having this backplane. And we didn't even know about it until just a few years ago. So can't hold that against your older builder. Some new technology coming along. That's our look around the parade of homes. We've looked at all the green features that we've got for you. We've looked at what makes a high-performance home a high-performance home. Now that you're here at the Parade of Homes, talk to your performing builders, your builders that are participating, ask them questions. They can fill you in on all the details and questions you might have at this point. We're happy to have you out here. Enjoy your Parade of Homes, and always think when you're building a new home, high-performance homes. Thank you so much. This is Mark Bostic, Columbia Green Building Council. See us at our website, columbiagreenbuilders.com.